Now, question 2. Complete the bubbles in figure 1 by inserting the SI unit which matches each of the physical quantities. You could use either the SI unit in words or symbols. So force is measured in newtons. So you could put an N or you could spell out the whole word Newton. Linear momentum, you just have to know that unit. It is kilogram meters per second. And that's for 2 marks. 2B, state Newton's third law of motion for 3 marks. For every action force, there's an equal but opposite reaction force. Part 2 of Part B. A Caribbean airplane on its way from the Piarco International Airport to the Grantley Adams International Airport flies horizontally in mid-flight. With the aid of a diagram and using Newton's third law of motion, explain how this happens. So your diagram could look like something that you see there going across your screen. You have 4 forces. There is the lift, upwards, weight, downwards, thrust, to the right, drag, to the left. So to explain how that happens, you could say something like, in level flight, the upward lift applied to the wings is equal but opposite in direction to the downward weight of the plane, while the forward thrust of the propeller is equal to but opposite in direction to the air's frictional drag on the plane. So you're talking about equal but opposite forces. Next, part C, part 1, define the term linear momentum for 2 marks. So linear momentum simply is the product of an object's mass and its velocity in a straight line. That's where linear comes in, right? Linear meaning in a straight line. Part 2 of part C for 4 marks. An 8 kilogram ball traveling to the east at 10 meters per second collides with a 2 kilogram ball traveling to the west with a velocity of 5 meters per second. After the collision, they move together. So you're to determine the final velocity of the balls, assuming that there are no resistive forces. So one of the first things you should do is choose which direction is your positive direction, because momentum is a vector quantity, meaning that the direction matters. So in this case, I will choose the east, which will be to the right, to be my positive direction, and the west, which will be to the left, as my negative direction. So after I choose my directions, then I should identify the givens. So mass 1 will be the 8 kilograms, which is traveling to the right initially at 10 meters per second. Then the second mass will be 2 kilograms, which is traveling initially to the left at 5 meters per second. So U2 will be negative 5 meters per second. I just realized my mistake here, but please, when you do it, M2 will be 2 kilograms and U2 will be negative 5 meters per second. Then I want to find the final velocity that they move together with. So I will use my principle of conservation of momentum, which basically says the total momentum before is equal to the total momentum after. So I have my formula M1U1 plus M2U2 is equal to M1V1 plus M2V2. And then I'm going to substitute my values. So it's going to be 8 kilograms times positive 10 meters per second plus 2 kilograms times a negative 5 meters per second. That's going to be equal to 8 kilograms times V plus 2 kilograms times V. Notice that on the right hand side, both V1 and V2 are represented by the same thing, because as the question says, after the collision, they move together, which means then that they share that common velocity, which we will call V. So 8 times 10 is 80, so I'll have 80 kilogram meters per second minus the 2 times 5, which is 10 kilogram meters per second. That will be equals to 8V kilograms plus 2V kilograms. So 80 take away 10 will be 70. So I have 70 kilogram meters per second is equals to 10V kilograms, because 8 plus 2 is 10. Then to find V, I'll transpose and divide by 10 kilograms. 70 divided by 10 is 7. Kilograms cancel out. I'm left with the units of meters per second. So the final velocity that they move off together with is 7 meters per second. Notice that it is a positive, So that means that it is to the east. That's the final velocity.